The Alien by Greg Delanty. I'm back again scrutinizing the Milky Way of your ultrasound, scanning the dark matter, the nothingness that now the heads say is chock-a-block with quarks and squarks, gravitons and gravitini, photons and photinos are sprout. Who art there inside the spacecraft of your ma, the time capsule of this printout, hurling and whirling towards us? It's all daft on this earth. Our alien who are in the heavens, our Martian, our little green man. We're anxious to make contact, to ask divers questions about the heaven dome you hail from, to discuss the whole shebang of the beginning and end, the pre-Big Bang untime before you forget the why and lie of thy first place. And our friend to say, welcome, that we mean no harm, would die for you even, that we pray you're not here to subdue us, that will put away our ray guns, missiles, attitude, and share our world with you, little big head, if only you stay. All right, this fantastic poem was by Greg Delanty, who's the author of several bodies. There's several books of poetry, including Book 17, Louisiana State University Press, 2015, Lose Strife, and The Ship of Birth. So, in case this wasn't made abundantly clear, this poem is talking about making first contact with aliens or extraterrestrial life, potentially. It seems to be a very hopeful one. But before I continue with all this, you might want to know that
what is this? Wait a second.
Yes.
What are we doing here? What is this?
Are we doing here? This is always a good question. So what exactly are we doing here? Well, this is SG2 on space. I would like to say the only weekly space show. Hopefully you're following us on YouTube, Shen Ge. This is episode 223. The question of, is life a cosmic accident? Before I continue, I want to bring in this guy.
Hey, Shen.
Hello, Leonard.
What up?
It's always good to... where's your headband, actually? You know what? That's my first question. But it's always good to see you.
They're in the laundry.
Oh, they're in the laundry. Okay, that happens once in a while.
How's it hanging?
It's good. I mean, you're wearing some amulets around your neck, so that's a signature sign of that, Leonard. You have not been replaced by a extraterrestrial organism. You're still you.
I am an extraterrestrial. No, I'm still me. Yes. Just kidding.
Okay.
Just kidding.
Whether or not Leonard is an extraterrestrial organism is up to the viewer to decide. But our episode is not going to be talking about that. It's talking about life on a bigger picture. Is life a cosmic accident? Oh, before I do continue, I would like to say thank you to our supporters on Patreon. So that is Sam Welsh, Kyle Baker, and John Graves. And so keep the ticker running at the bottom. If you wish to be a supporter, since you like the show, you can go to patreon.com/SG2 on space. You can even follow us without paying anything if you just wish to, demonstrate your support tacitly. Anyways, let us continue.
Sure.
So Leonard,
I was going to say thanks for stopping by.
That's also true. And for our viewers 10,000 years in the future, if you're watching this, obviously not live,
we care
you are
for them.
well aware that everything that we're discussing here has already been answered by you, I'm sure.
Probably,
but
yes.
Probably by that point. But without further ado, let us go with the opening question. And the opening question is, okay, drum beat.
Well,
is life common in the universe, or are we alone? All right, Leonard, let's hear it.
Well, sure. I mean, this is the thing that it always comes up in the popular science promoters. If you just if you imagine for a moment that we're not alone in the universe, then somewhere out there in the vast expanse of space, as let's see, Bill Nye would put it, and others, other civilizations are thriving, and it's just been that's just been a commonplace. For decades, the idea has captured our imagination and driven scientific inquiry. But, despite decades of searching, we've really found no definitive evidence of any kind of extraterrestrial life whatsoever. Of course, if we did see it, we have a tendency to dismiss it, right? We did talk about the Oumuamua episode, the asteroid that came through and had all kinds of peculiar characteristics associated with it. But the thing is, it raises a critical question. If life is so common, why don't we see any signs of it at all anywhere?
Fermi paradox.
So that's
right. But before we talk about the Fermi paradox, I think you also wanted to talk about, we want to talk about Francis Drake, right? Or Frank Drake.
Well, yeah. So we'd like to delve into that that Drake equation, and I think it dates from about 1960. And Frank Drake was a astronomer and astrophysicist, and he was sort of a pioneer in the search of extraterrestrial intelligence as a serious sense. So his influence was creator of this thing called a Drake equation that's used to estimate the number of extraterrestrial civilizations. So it's a very optimistic viewpoint, popularized also by Carl Sagan. I think you can go on YouTube and find Carl Sagan talking about it. We can actually, yeah. So if you can show it there.
I mean, look at this wonderful scrawling. But I mean, yeah, let's explain what each of these are.
Okay, so.
Oh, by the way, this is from the website of SETI, which for the viewers, it's the Search for Extraterrestrial Intelligence, which is an organization. Was that founded by Carl Sagan? I can't remember. But anyways.
No, actually, I think Frank Drake had something to do with it.
Oh, really?
Okay. I think that he had. So the idea is that there's this number n, capital N. So this equation is a sentence, really, and so it says that n is the number of civilizations that we propose we might be able to communicate with, right? Mm-hmm. And then there's r, and that's the rate of star formation. Really, we could say in our galaxy. And we think that's fairly well understood. It's not controversial. And then there's the fraction of stars with planets. And when I was young, I mean, when I was, I don't want to say teenager exactly, probably young adult, when I became interested in astronomy and physics and science and all the things I'm interested in.
You're interested in quite a myriad of things.
This number was not really well known. Fraction of stars with planets. It was proposed
So when you were a young adult, what did people think it was?
I think it was all over the place.
Oh, okay.
We didn't even really know how our own solar system was formed. So there were, I remember Time Life books that I would read, even as even quite young, before a preteen. Mm-hmm. And it would explain all different kinds of theories about how planets were formed. Some people thought that maybe another star, it was a very rare thing that would happen, where another star would come and drag some of the material from the sun away, and then that would condense. But we now have a pretty good idea about how planets form because we observe them from the Hubble Space Telescope. We see a protoplanetary disk form and condensation of nebula and that sort of thing, which we can do in another show.
The formation of planets, we can definitely do another show on that.
If we haven't already. Mm-hmm. We've done so many shows, I've kind of lost track. But anyway, we now know this number is very close to 1. Okay, fraction of stars.
Because with the latest, what do you call it? Telescope.
Kepler, yeah.
We've done episodes in the past where we talked about extrasolar planets, and literally every star system that we have observed has
many planets.
Yes.
Yeah.
It's remarkable.
So we can check this one off. This one we know it's 1, or maybe it's 0.99, something like that. We might be able to find a star without a planet around it, but so far it looks like every planet that we've looked at, with the techniques that have now been developed, we see planets. They're very common. So that's not under the that's not questionable anymore. And then the other one is the number of habitable planets per star system. And so what I think this means is it's the number of planets that, N sub E would be the number of planets that are in the habitable zone. In other words, the place. Sometimes you'll see Goldilocks zone, where the eccentricity of the orbit is not too great, and it doesn't go to a place where it gets too hot or too cold.
But for our viewers who don't know astrodynamics, eccentricity just describes how non-circular the orbit of a planet is around a star.
Right. Exactly. And I didn't want to emphasize that too much. I think people get the idea. It's the Goldilocks zone, and we think that number is not. That's not one. That's not. That's not large, but of the fraction of stars, then of the fraction of stars that are habitable, this is a significant number per star system, something like maybe 0.5 it's some large fraction, something between 0.01 and 0.5 probably.
Okay.
So and then I want to skip over the fraction of planets where life actually emerges, because this is what we're going to be talking about.
Right. Okay. We're gonna skip over that.
The other one is the fraction where intelligent life evolves, and that's some number that could be once life evolves, we see it. Once life does emerge on a planet, on Earth anyway, we see it pretty rapidly within hundreds of millions of years evolve into complex forms. And then there are, several times on our planet, at least 7 times on our planet, we've seen complex ecosystems where different organisms evolve and interact with each other. And then there's mass extinctions that occur from usually asteroid impacts, as believed, or resource depletion and so forth. So this number is probably not small. Okay, if life emerges, then it's likely that it will evolve into complex forms. Arthur Clarke actually, in one of the books, maybe it was Childhood's End, or one of the books, he talked about how the astronaut. This was before Apollo, before the people landed on the moon, and there was speculations, and so his astronauts landed on the moon and found very complex organisms that were living on the moon, even though the environment was very, very hostile there. Now, this is all fiction, of course, but his idea was that if life emerged someplace, it would evolve into complex forms and exploit, the characteristics that we usually attribute to complicated, multicellular organisms. Anyway, that's neither here nor there.
Well, sci-fi loves to speculate about how common extraterrestrial life is.
But a lot of I'm sorry, yeah. No, a lot of times you'll hear people talking about, well, there could be primitive forms of life, perhaps on Mars. So a primitive form of life that exists on Mars for hundreds of millions or billions of years. What's keeping it primitive? What's causing it to continue to be primitive? And I think that's a question that's sort of arm waved away, because if life evolves, then you expect it to. If life appears, then you expect it to evolve. You don't really expect it. We don't have experience on our planet.
But what about I could easily think of single-celled organisms living in some harsh environments, and then that's life, and it just stays like that forever, or for as long.
That's a fair point. That is a fair point, and we do see on Earth bacterial forms
isn't there technically more life on Earth that's underground than above ground?
That's what I've heard, so to speak.
I've heard it too, but that may
but
not
the
be.
point is, I mean, there's no doubt there's much more like simplistic life compared to complex life on this planet. Like if
That's
you just look at
true.
the quantity. So
That's true.
But
So
anyways,
I didn't really want to go into that. That's for maybe another episode. But I just wanted to mention it. And then the next term here is that fraction of planets with life on them that develop a detectable technology. In other words, they've developed television and they broadcast out, and we're able to detect
you just
it.
said television is. I guess television is considered detectable. Because it's broadcasting.
Right.
Wait.
So yeah, television's I think in the film Contact, the Jodie Foster film.
I actually
Alien
read the book by Carl Sagan, actually, which is somewhat better.
It was by Carl Sagan. So the aliens detect the television broadcast from the German television broadcast of the Summer Olympics in 1936.
The Nazi Germany one.
Yeah,
right.
and so everybody's outraged. I don't want this to be the first contact that people see. So, so that's that. I mean, and of the many different ways that could express itself with radar and or however we manipulate our environment that could be detectable from extrasolar, extraterrestrial distances. And then the longevity, that's as highly uncertain, is how long we continue to broadcast, how long we continue to make ourselves present.
Is this so? When you say like L, that means like is this like? Did we? I guess one of two scenarios in my head goes. One is that we destroy ourselves, so we don't broadcast anymore, or two, not destroy ourselves, but somehow our civilization ends. Or two, we advance beyond using radio communication, so we don't use it.
That's right. Yeah, I think I have read that our we're with the advent of cable, and different kinds of internet broadcasting. We're not broadcasting as much as our radio emissions are less than they were 25 or 30 years ago. So for whatever reason, however long our technological civilization remains broadcasting, as it were. So those are the terms in the Drake equation, and like I said, it's a sentence, and the equals sign kind of connects those two things together. So all of these numbers together that you multiply together will formulate it's a way of organizing the expectation of the number of communicative civilizations. And I'm going to center on that one there that I skipped over earlier. Now, the fraction of planets where life actually emerges, because in popular discussions about this, it's always assumed that, that must be if a planet is habitable, if it's capable of producing life, then life will appear there. So that's the conventional assumption, right? And so the conventional assumption is that life emerges easily given the right conditions. The counter argument that I'd like to advance.
So basically, the thing is, like, people naturally assume that F sub I is equal to 1. Like,
I think that's right. I think if you listen to Carl Sagan's talk on YouTube, and other popularizers, they just arm wave that away because surely it's 1. Okay. But the counter argument for that is that there really is no solid scientific framework for this is something called abiogenesis. In other words, that life emerges, that the planet has no life on it, right? And then life then emerges. And so in the early 50s and up through the 60s, there was a lot of enthusiasm about this because there was an experiment that was attributed to Miller-Urey.
And you're saying the attribution is not exactly accurate?
No, the attribute. You mean the attribution?
Okay. Go ahead.
I'm going to say there was a lot of excitement about some work that was done at University of Chicago by a graduate student named Stanley Miller, and his professor Harold Urey.
Yeah. Sorry. Mm-hmm. I don't know why I find that a weird word to say. Okay. So essentially, I remember reading about this, that this was like, oh, wow, they formed life out of like non-life.
Right. And so what they did not form life, but it was what was exciting about it was that they conducted this experiment. It was like an intriguing experiment to understand how life might have originated. And so the way it proceeded was that they tried to, in a beaker, a big spherical glass bottle, they tried to simulate the conditions of the early Earth and understand how life might have originated. So what the idea was, they aimed to replicate what they believed the atmosphere of the early Earth might have looked like. It was a mixture of methane, ammonia, hydrogen, and water vapor, and that's all. So methane has carbon, ammonia is nitrogen, hydrogen, and water vapor. And so what they thought is, well, maybe if we put an electrical spark in this atmosphere, and so they put some probes in there, and in photographs of the instrumentation, you can see that there's these two probes that go through the glass, and they're close together. And so they introduce an electrical spark. And so the idea was, they thought maybe this imitates lightning strikes. And so this was the conditions of the early Earth maybe would produce building blocks of life. And so they ran it for about a week, and they discovered that it produced a number of amino acids, which are building blocks of proteins.
This is a guy, Harold Urey.
Yeah.
Okay, sorry. Go on.
So they and that's fine. Yeah. So it's like, so building blocks of life, amino acids are building blocks of life, and it's like, whoa, okay, this is awesome. And I remember learning about this as really quite young. And so the idea is, well, suppose we just let it run, maybe we can just let it run for a week or something like that, and it'll eventually then maybe little life forms would form. But that never happened. And it's been and this experiment has been repeated many times. They've tried other things, like besides electric spark, they've tried to use ultraviolet, like sunlight, or electric spark and sunlight, and different variations of it. And so it's never gone any further than producing some amino acids. And although this was, it's groundbreaking and demonstrated the possibility of like kind of prebiotic chemistry, it doesn't answer the question of why there are more complex, why more complex life can evolve and appear. And so that's where the story.
You're saying it's like the hype about, oh, well, they formed amino acids. That means, well, they formed life. That's a misconception. So amino acids does not indicate life.
They did not create anything that was self-replicating and so forth. So
speaking of which, Leonard, before we continue, I would like to ask you, what is life? Did we answer that?
Well, in my mind, life is that, to me, that's not a complicated question to answer. It's chemistry that self-replicates according to rules, that according to some genetic type code, and it doesn't necessarily have to be based on DNA, although all life we know of does, and that it's capable of both replicating, but also in the larger sphere of the definition, able to adapt and evolve gradually according to environments. So to my mind, I know people have a lot of difficulty and there's a lot of hand wringing around the definition of life, but for me, I don't really understand why that's complicated.
So yeah, so basically it's something that has genetic code that replicates and is also able to adapt and evolve according to the environment. So
right.
All right, so this is the definition of life we're going with.
So it actually would include viruses. Some people say, well, viruses are not living. Okay, well, they're not living all by themselves, but they are living they are elements of life in that they're dependent upon larger cells to replicate. And it probably does not include the prion phenomenon. What's the prion phenomenon? So there's a disease that we sometimes hear about, and we talked about before. That's responsible for the mad cow disease. So it's not a life form. It's a defective protein that's able to. It's more like a poison than. So it has some characteristics of a living form because it's sort of like makes replicas of itself, but I'm really not so comfortable treating it as a living organism, but I'm not really strongly.
So possibly some viruses are considered life, but let's just continue on.
Let's continue on. We're sort of getting off the task.
Well, I just want to make that clear, but all right. Okay, so point is Stanley Miller.
Urey.
Yeah.
Urey was his professor.
They did all these experiments. They produced amino acids, which was pretty interesting. But that is not an example of abiogenesis.
No, it's not abiogenesis. Okay, and so the story becomes kind of murky at that point. And I want to say, if the origin of life was easy, right? If we understood all of these things, if we weren't working so hard to try to understand it, then the answer to what F sub L is, would be easier. All right, but the fact that this is so difficult. Okay. Now I know there's lots of things that are difficult, but the contrafactual would be Miller and Urey put some chemicals in a bottle and shook it up and heated it and put sparks into it, and then there were little amoebas that were growing inside of it. That's the contrafactual. If that happened, then we would have a good answer for F sub L. It's close to 1, right? But what we see is that we have no evidence that of any such of a phenomenon, and that researchers are working very, very hard to try to figure out where life is coming from, and it'll take us into this area called RNA world, and so forth. But the thing about Miller-Urey is that the complexity of biochemical systems. I mean. It just makes the odds of life forming spontaneously incredibly low, at least in my mind, and actually practically zero, right? So,
well, I mean, they only try this one kind of methodology, right? So
no, this experiment has been repeated many times and modified, and people have thought of other things to do. I think that. Some people think that the formation of clay has something to do with, like maybe if there was clay, which is a very finely divided mineral, could create a substrate, and so they played with this in all different ways. But the bottom line is that that fantasy counterfactual that I just described does not occur. It is not something where you just put a spark with early atmosphere and create little
like the yeah, understandable. It's not like you can try all these different permutations of what could possibly be emulating the early stages of Earth.
That's right.
Inorganic molecules, and then be like, oh well, naturally life originates, but no, nobody has shown that to be true yet.
That's what we're saying here.
Okay.
So if life had been easy, then our perspective would be completely different. And so the other thing is evidently then a lot of what we see of life is irreducibly complex. I don't like to use the term irreducible complexity because that's a lot of times that's used by religious by the religious
okay.
people.
So the religious people are going to say, "Well, look at this!" Like,
right?
It's like, it must have been God that made us, right?
Right, and they're not wrong about that. In my opinion, in fact, I don't think that's wrong. Right? So that is a hypothesis. Okay, that's a hypothesis that fairly supports a supernatural creator that could solve our problem, right?
Okay, so let's since we don't know how to go from these amino acids, whatever, these little molecules into actual like RNA or
yes,
for that matter DNA or any of it. Like that gap is missing. We don't know how that happens.
Yeah, and that's one of the things that I wanted to talk about to illustrate how difficult that is. I just wanted to talk about one component of every cell in the body. Every replicating cell in the body has a machine. It's a little biological machine called a ribosome, and it's a complex molecular. Literally, it's a machine, and it exists in every living cell, and it's responsible for protein synthesis. And the protein synthesis are the things that make up your cell. And I think that, all of the things that have to do with the structure of cells and your body, living organism. And so the ribosome is a little machine, and it's responsible for protein synthesis, and it does this through an incredibly, it's a mind exploding, highly intricate process that involves the coordination of RNA and proteins and error checking, and it's so remarkable in its structure and interdependence of variable biochemical components that it's just to me, it's just unbelievable that this thing could sort of become spontaneously assembled from abiological material. So just to give you an idea, the ribosome consists of two major subunits, and each is made of what they call ribosomal RNA. Those are the things that construct the ribosome itself, and so it's actually made of RNA. And the ribosomal RNA forms catalytic core of the ribosome, while proteins help stabilize the structure. Okay, so together, so there are these components, and they're coming together. Yeah.
I wonder if you have a picture of this.
I sent you some slides.
Okay.
I did.
But okay, point is, it's complex. That's what I'm hearing.
Yeah. I do have a slide. I think I sent you, so you can't open my slides.
When did you send those slides? All right, let's continue. I'll see if I can find your slides in the meantime.
We're having a So there's a YouTube you can post. There's a YouTube links that you can show where so the process is so sophisticated it's hard to imagine how it could have arisen spontaneously without a guiding mechanism. So any theory of abiogenesis, that means creating life from non-living things.
Yeah.
It is really essential to explain not just the formation of the simple molecules like amino acids, but also the emergence of a highly complex system. And this is just one of the things that's in a cell. So the ribosome, to me, it's kind of a testament to the extraordinary complexity of living systems. And any theory of life's origin has to account for how such a machine could evolve as a function, could evolve. Its function is so central to life that I'd argue that it cannot be just like a simple afterthought. So the thing is, the reason I'm so impressed with the ribosome is because that is the machinery that reads the DNA. Ultimately reads the DNA. It doesn't read it directly. It reads it through the RNA, messenger RNA that comes to it. And there are videos that you can watch where the RNA is read like a complex card, like a magnetic tape, and it's reading the information through, and it strings it through, and as the machine turns around, it creates
well, this is not exactly sure.
Yeah, something like that. No, there aren't any still pictures that really do it justice.
Understandable. All this is happening all the time. All right, go on.
Right. Yeah. So what I guess what I'm trying to say, and this is not motivated by any inherent religious idea. It's more because I'm trying to push back. I'm trying to create a falsifiable argument. If you're going to say that the Drake equation predicts that there are millions, or as Carl Sagan, literally he said hundreds of billions.
He loved to use that word.
Yeah. And I was very fond of Carl Sagan.
Yeah.
So, so this Drake equation that we were looking at, it's quite possible that all of those terms multiplied together will only give you 1 or even 0. If a priori our Bayesian assessment of the number of civilizations, or number of living, even planets with living organisms on them, could very well be 0, even though we know it's at least 1. So,
well, yeah, I mean, we exist. I think you're alive.
Right, we exist. Yes,
Leonard, if you're not alive, let me know.
No. So, but if we were to start fresh, right? Okay. If we were to start fresh and estimate the number of stars, number of planets where life actually emerged, we might, just based on the arguments that I've been articulating here, we might just end up with 0. So that so despite the fact that all these other numbers are large, f sub L may not be large enough to compensate for that fraction. That fraction could be 10 to the minus 50.
Right. Just a refresher. F sub L is this thing.
And I think that's okay. So don't hate me for bringing this to you. This is. I
mean, I'm not going to hate you for saying anything.
Yeah, but some people are, because this is something that we want to believe. Right? Yeah, I want to believe it. I want to believe that
watching this show right now, feel free to put some comments to, like, if you don't.
Oh yeah, like, subscribe.
Yeah. Well, no, not just that. Like, your thoughts about how common or uncommon life is. All right, go on.
Right. Yeah, that's that. Yeah, it's good to pause and urge people to do it.
Your disclaimer just now was like, despite you're saying about how like people should not hate you for something. What were you going to say?
Oh, I was going to say, look, this is not what I want to believe. Okay. this is not what I want to believe. But you've heard me say, I don't choose what to believe. What to believe chooses me. And this is one of those cases where I sit down and I think, and I try to understand how the ribosome could emerge. And, nothing, and actually, people could say, well, maybe there's alternative biochemistries that exist. Well, maybe the issue is, it's like, maybe they're silicon based, but the fundamental problem is assembling complex self-replicating systems from non-life. And that's the main problem. And then some people say that, life evolves into, extreme environments, but that's still, again, it comes back to how does this self-replicating system appear spontaneously? And another argument is that life appears to have developed on Earth very quickly, and I think that within 300 million years. So 300 million years, well, that's still quite a long time.
300 million years is a remarkably short amount of time for life to develop.
Well, compared to 4 billion years, it's not remarkably short, but it's a fair fraction. I think that that's the best argument, that it could be common, but it's still the fact that we don't understand how life started. The fact that it's not easy. It's not only that we don't understand it, because there's lots of things we don't understand, but the counterfactual. If it were easy to emerge, then you connecting that with the fact that we can't do it ourselves. It's easy, right? We posit that it's easy because of large numbers or something. We assume that's an assumption, but we can't do it. Okay, those two things are not consistent. If it were easy, then we should be able to do it ourselves. And I argue that there has been some work with RNA and making these little proto-ribosomes type of things, and there does seem to be something there. But the researchers that are working on and writing these papers, they're having to go to extraordinary effort, and also they cheat a little bit, like they use some enzymes and that kind of thing. So anyway, so the bottom line is, I'm all about understanding this phenomenon. I want it to be true that there are hundreds of millions of civilizations, and that SETI is worthwhile. But I think that we ought to just face up to this fact. So, and that's all I wanted to say about it. Let me see. I got some notes here. Let me see. So we talked about
what about was it you were saying something about Bayesian argument?
Well, this whole thing is Bayesian. So Bayes was a mathematician in the, I want to say 18th century. And he came up with this idea that there's two ways you can do statistics. You can measure statistics. You can measure the frequency that something happens. And that's what most people think about. But then the other way you can do statistics is that you can look at the structure of your system and then make an assessment of how likely it is to happen. So weather prediction is Bayesian. In other words, you have a model of your system, and then you run it forward, and it tells you what the weather's going to be. So that's a Bayesian approach. That one of the fundamental things about that is the weather tomorrow. What's the weather tomorrow going to be? The best estimate, you start with the weather today. So the weather today will influence what the weather's going to be tomorrow physically, and so that's a Bayesian assessment. So that's all we're talking about, and that Drake equation is what we call Bayesian approach.
It's a Bayesian approach because you're basing your prediction based on where you know right now.
That's right.
Okay.
And we didn't mention the Fermi paradox, or maybe we
Yeah,
mentioned it.
we like glanced over it briefly. So tell me about the Fermi paradox.
Fermi's question, it was phrased in the 1950s and early
See if I
50s,
can-
probably right around the time that the Miller-Urey experiment was.
This was after the Drake equation, right?
No, the Drake equation came after.
Oh, okay. Thanks for
The
that.
Drake equation is kind of straightforward. It's kind of like a way. It's not.
The SETI website has a hilarious.
Oh yeah.
All right, go on. Sorry,
Run
that's
empty.
kind of funny.
Yeah. So Fermi's question. The whole history of that is apocryphal. I think it was during lunch, and he mentioned it on a walk back. He says, "Well, so where is everyone?" And people were also started talking about UFOs in the early 50s as well.
Well, yeah.
And so the possible explanation is that life is rare. In other words, that number that we're talking about is low. It might very well be zero, or
the
just
Fermi paradox is basically, hey, if there are so many stars, planets, habitable,
That's right.
possible planets out there, well, where are they? Where are they?
And some variations of it go something like this. Look, an advanced civilization will develop self-replicating robots or machines, and we'll send those out. Where are they? Yeah, we'll send out some robots to another within the next couple hundred years. We'll develop the technology.
I mean, I was just thinking, I thought about doing this. I haven't done so yet, but I was going to make a simulator, right? Basically knowing the distribution of stars, with every star system that we know have planets. And so it's like, if you have at least one intelligent civilization, the universe has been around for a while, a number of billions of years now. So you would have thought that they would build these robots, which would be self-populating, so to speak, and they would have explored every single star system in our galaxy by now. Right.
That's von Neumann machine,
right? Like, and every advanced civilization, you would naturally think they would progress to that level to exponentially explore space. But since we don't see it, what's happening?
That's right. So there has to be explanations.
Yes.
So some people say, well, obviously civilizations destroy themselves. Intelligent life does not appear to develop detectable technology. That could be very rare. In other words, and the evidence for that is that on Earth, we've experienced 7 major extinctions. In other words, each time complex ecosystems developed for 100 million years or so, it didn't develop any technology, right? So it's only in this last epoch. It's only in this last epoch that we've developed to produce technology, or even to have really a conscious, to develop consciousness of ourselves, a sense of self. Right. So that happened during early life. There was complex ecosystems, with predators and prey and all that kind of stuff. And that's happened 7 times. And each time we had extinction event.
We had 7 mass extinction events in the history of life on this planet.
Right. Where almost.
Right. Go ahead.
Right. Where the whole ecosystem collapsed and almost all of the organisms died, and then they started to re-evolve and fill in those ecosystems again. But only in the last one did we have, only in this last epoch that we live in do we apparently have organisms that have a sense of self. Even I'm talking about humans. We know we are alive. We know we are. We're self-conscious, right? And we've developed technology and so forth. So all of those things. So that, so Drake's perspective and the Fermi paradox, while the Drake formulated his equation to estimate the likelihood, the Fermi paradox highlights the contradiction between what we expect and the lack of any observable evidence. And so for me, I mean, what I wanted to articulate in this kind of essay today, or our conversation, was that the simplest explanation, or one of the simplest explanations for the silence of the universe, is that the fraction of planets where life actually emerged, that is F sub L in the Drake equation, is effectively 0.
Yeah. I mean,
so emergence of life is a profound mystery. And I think it's wrong to assume that it's greater than 0 without some kind of rigorous mechanism. So,
anyway, I could also, I mean, I feel like I know I don't know enough about biology to say anything in that regard.
Well,
but like, just my take on it is, just because we don't quite understand how abiogenesis can occur doesn't mean that it can't occur.
Okay, that's true. But think about what you're saying. It's like, just because we don't understand it, the counterfactual is it was easy, right? Miller and Urey put air and different kind, and they spark, and then they come back a week later, and there's like a little civilization, a little age of empires that's developing in there, and there's little wars going on, and
okay,
I mean, that didn't happen.
That did not happen. So I mean, the creation of life is definitely much more complicated than some
and we don't expect to have we don't expect to take like dead stuff and put it in a vat and living things come out. I mean, in ancient times, people thought that that's where mice.
Yeah. So they thought what is it? The flies just transformed from like dead meat or something.
Mm-hmm.
But really, it was eggs that they didn't know that was there.
They didn't know. They didn't know that, and so that doesn't happen. And when we don't know how to make life, right? But it's like, it's fine. I know it's complicated. That's my point. It's complicated. And so it didn't have to be like that. There could have been a universe where it was so easy that you just snapped your fingers and life would fly off, maybe in some kind of universe, but not in this universe. So that's why I say, and we do have to explain the Fermi paradox. We do have to explain the situation, the circumstances that we've tried to have our conversation about today. The end.
Right. So
you don't seem happy. I've made you very unhappy. I've made all our audience very unhappy, and they're not going to tune in anymore.
Why? Do not presume to know how I'm feeling like this. I mean, I actually enjoy hearing this talk. No, I'm perfectly happy.
Yeah.
In many ways.
Anyway, that's all I had to say about it. So, did you want to talk about anything else? Otherwise, it's like people should like and subscribe and make your comments. I mean, actually, really would like to hear what people have to say.
I would be curious as well. So, for sure. I mean, how many people are believers of? I shouldn't say believers of Leonard, since it makes you sound like a prophet.
No, I'm not. It's not a believer in me. It's not. That's not it at all. I'm offering this proposition to explain some of the things that we observe. I'm criticizing the popularizers who just arm wave their way through this without thinking it all the way through, and then whatever, I'm open to being corrected. Something I missed, and I'm sure there are things that I've missed, but. Anyway, thanks for stopping by.
Yeah. So, how do you explain all those UFO sightings then? Hoaxes.
That.
I was gonna present another one.
You wanted to talk about UFOs?
Sure, why not?
Sure,
So,
So
it's one of
I
my
have so
favorite
much
topics.
fun every week, and then I have to pay for it.
Oh my god.
No, I'm kidding. I'm kidding.
Well, let's see what this one is.
I really am kidding.
Oh, look at it. Okay, I have no idea if this is. You know, it always amuses me. Like, I'm not saying I'm a believer in any of these videos, but it's always intriguing in my head, at least. Okay, let's
Well,
see.
you really
Let's see if I can
can't.
pull this up.
You really, yeah, you really can't. Well, okay.
Okay.
So what do we got here?
I don't know this random thing. I haven't played this, but apparently some cigar-shaped UFO over Germany. Let's see what this says.
In the 19th century, UFOs were cigar shaped.
What the heck? Okay, stop. Well, that was a weird
Careful,
ad.
End up at a porn site or something.
Please stop. What? Give me a second. That's let me pull up another video that does not have an ad. I hate these ads.
You, my friend, are being scammed
Ah.
into paying for your TV channel.
Skip.
Here's how.
Okay.
What's your plan when a dangerous blackout strikes?
Oh my gosh. I should have added an ad blocker. I normally do that.
Do you have a zombie plan? Don't tell people your zombie
Okay,
plan.
here. Try this one. This one's better. Okay, let's do this. Okay. So I'm gonna mute this. This is supposed to be something. Okay, so they've observed these things near active volcanoes quite a bit. All right, these like light things. See, look at that. What is that?
It's embers of
Okay,
burning.
skipping all this.
Yeah.
Okay, so and that thing. So I guess this was on January 24th, 2017, and that was over around Mexico City. That's what it seems like. So yeah, okay, skipping these random volcano pictures, people talking. Yeah, like something like that. Do you see that? Like, what could that be? And look at that. It like flared up.
Gosh, I don't know, but we hardly get a chance to look at it, do we?
Here. Let me see if I can. Yeah, look at that slow motion photo or video. Like, it's like a
I don't know, Shen.
giant orb that flew over this thing and like brightened. Like, what could it possibly be? Here, let me see. Is there any more?
I don't know.
Let's go back to this one. See that kind of. So I mean, it happened more than once. I mean, like there's a bunch of these things going on. So I don't know. I mean, personally, if I'm gonna go a little bit on the crazy side of things, I might say there's a hidden alien base underneath the volcano.
Yeah, that's probably it.
I mean, okay, all right.
Of course. I mean, I'm open to that. Just
I mean, strange things in the sky presents a lot of questions, but you know,
Yep.
I don't know what to say. Who knows? All right, Leonard remains skeptical, obviously, given that our whole entire
I'm open.
episode. But yeah, interesting. So now, with all that was said, if anybody actually comes across any circumstantial evidence of any sort that you can't explain, do share some of that as well on this channel or these comments. Hopefully with a better video than these fuzzy ones that I've.
Sure, but if the video is crisp and clear, then it's presumed to be fake.
There's no
See?
winning here.
There is no winning. That's right. Okay. And that gets into Bayesian, the Bayesian hypothesis also. It's like, what is the most probable source for these unexplained things? And they're fake. I mean, that's the most, right? And there's nothing you can do about it. I mean, because even if an event like the movie The Day That Earth Stood Still occurred.
Okay, yeah.
In that film, that's a 1952 film with Michael Rene. The Day the Earth Stood Still, not the 2009 one. That one should be expunged from history.
Do not watch the new one. Yes.
Do not watch that one. That one should be all of the prints from that. Watch that one. Okay. So in that one, the spacecraft comes in. The spacecraft comes in, and that's not Patricia Neal being held by the robot monster. And that scene does not appear in the movie.
Well, this is a terrible movie poster then, but
yeah, but well, it is an awesome movie poster. I really
I mean,
want
it's
it.
a great
Okay.
movie. Yeah. Okay.
Yeah. So, but Michael Rene and Patricia Neal and Hugh Marlowe, and this is so in this film, the spacecraft is a flying saucer, and I believe 1952. The spacecraft flies over Washington D.C., over the Smithsonian Institute, and it lands in a baseball park in front of the White House and on the Capitol Mall, and thousands of people experience it. If that happened, then I would concede that those were aliens.
You're waiting for extraterrestrials to willingly reveal themselves to us. Like blatantly, just saying.
Well, not necessarily. Here. I mean, the Pentagon could, go and shoot it down, and then it could land there, crash onto the mall. I could, then I would consider that a very compelling event. But even if I saw it, I would be very skeptical. I'd probably have to go see it in person.
Oh my gosh, you're like the supreme alien skeptic.
Well, no, I'm just not gullible. I mean,
thanks. Okay.
So we talked about Oumuamua, do you remember we talked about Oumuamua?
Yeah. Oumuamua was very strange.
Okay. So, Oumuamua was an extra solar comet, or not a comet.
Say Oumuamua.
I like saying it. It was
Oumuamua. We did an episode for those watching. We did do it. If you're still with us, we did do an episode on Oumuamua
right
last year about the first extra solar object that was detected in our solar system. Unfortunately, it pretty much swung by and went out of our solar system before we could do anything.
And there's a I guess he's a Harvard physicist. I can't remember his name.
Yeah. And he was saying about how it's possible, like the explanation would be it's extraterrestrial spacecraft.
It's possibly an extraterrestrial spacecraft, maybe a light sail type of thing, or a disabled one. And the reason was it was doing things that were not natural, or it appeared to be doing unnatural maneuvers. And so what is the most likely thing? I mean, we're constantly told that life is, and that is not a photograph of it. There are no photographs of it.
There are no photographs.
That's an artist's impression.
Photograph of it, in my perspective, is probably an alien spaceship, but that's my view.
Right. Well, I mean, if you remember when we did that show, I was open to that. I suggested that. I thought maybe it was probably a shockingly high.
It was very long, elongated, right? Like it was unnatural.
That was one interpretation of the very weak imagery that was available. So that was an interpretation of it. So, but at that time, I think I said, maybe 5 to 10% probability that it's an extraterrestrial technology, just because it did unnatural things. And then our priors are life is common throughout the galaxy. So what is the extraordinary? What is the extraordinary claim? Right.
Yeah.
Carl Sagan would say extraordinary claims require extraordinary evidence, but something extraordinary could just leave ordinary evidence, So,
but you just said yourself, if an alien spacecraft, like in the movie, right? You would actually not believe it still until you go to.
I would have a lot of difficulty, believing it. Yeah.
All right. Because of
because it's an extraordinary thing.
Well, you will ask basically the whole premise of this show, for instance, it's like, well, like how did life start in the first place? It's so uncommon. Like
that's
so
right.
Because of that, you would have a very high doubt if
I do
spacecraft lands at the White House. Say you'd be like,
yes, I have a lot of skepticism based upon the theme that we're talking about today, which is that the probability of life appearing is 0 or very close to 0. I mean, I propose.
Obviously not.
I offer for peer review. Okay.
Okay. Understood. All right. I still prescribe to the notion that must be fairly common, but then you can call me gullible. So
Yeah. Well, you don't address the. I don't know if gullible, but you don't address the issues that I have. I'm proffering, or I'm offering a conjecture and refutation, that conjecture that needs to be refuted.
I forget, but we talked a while back. There was also some chemical that you said that was that replicates.
Well, the prion does.
No. There was something about how it is very inconceivable why it was like that. Like I forget exactly. Like some chemical that was like, is it left-handed or right-handed or something? I can't remember.
The chirality of chemistry of life. Many chemicals, including the amino acids.
That's the word.
They have, and we talked about chirality with respect to neutrinos also, but that's not what we're talking about. We're talking about the chirality of chemistry. Whereas an amino acid will have things like this, and then there's a mirror image of it,
right?
And life only uses one of those chiralities, and all of the other pieces are not bioactive. One of the drugs that was developed in the late 1950s was called thalidomide. Okay. And thalidomide was I think it was a sleeping aid or a tranquilizer that was developed, and it was discovered, unfortunately, that the isomeric form, the left-handed, it was only the right-handed one that was effective as a drug. The other one was toxic, was a teratogenic chemical, and caused these profound birth defects in many children, including some children I grew up with who were missing, who were deformed in that way, who had some disabilities.
In living organisms, one typically finds only one of the two enantiomers of a chiral count. For that reason, organisms that consume a chiral count, you can metabolize only one of its enantiomers. Okay.
I'm sure everyone understood what you said.
I mean, basically what you described. So yeah.
So, yes, that's very mysterious. That's very mysterious.
Why
can we replicate? Can we synthesize an organism that's entirely composed of the opposite chirality chemistry? I think we need to be really careful and not do that in the Wuhan lab, but do it in some other lab that is isolated better.
Right here, it says like the origin of homochirality in biology is subject much to debate. Most scientists believe Earth's life's choice of chirality was purely random, and that if carbon-based life forms exist elsewhere in the universe, their chemistry could theoretically have opposite chirality.
That's right. And also, it's quite possible that we could synthesize such an organism, and I don't think we should be playing around with that. I don't know what the consequences of that would be.
If you synthesize an organism with the opposite chirality of life on this planet,
I don't even really want to say it, because I'm really quite I really would be very worried about that. That needs to be done in. I'm up for doing research on that, but only in
you just said yourself though that we don't even know how to synthesize life at all. So like,
I didn't say I know that, but I'm sure So any efforts of it are going to be pretty crude and amateurish, and not very effective. If you're going to be playing around with a opposite chiral life form, synthesizing, if that technology could be developed, I think it needs to be done very carefully. You're not hearing me. You're not hearing what I'm saying. I think it's very dangerous. I think such an organism.
Play around with chirality when it comes to life forms.
I didn't say don't play around with it. I said it's very dangerous. I think there's tremendous risk associated with it, And
So
I can't
the same-
really articulate why I think that, except that
right.
a,
Well, the
a
same
replicating.
molecule with the opposite chirality could have completely different characteristics that are possibly dangerous. That's what you're saying.
Could be toxic. I mean, the
Right.
thalidomide example, just kind of.
Yeah. Wow. Chemistry is so interesting.
Yeah. So I'll repeat the kind of interesting point that I made a moment. If you're going to be doing experiments with chiral, what's it called, the opposite
Chirality.
chirality, living organisms, synthesizing living organisms, that we should not do it in that Wuhan lab.
Do not do experiments with chirality
In the Wuhan lab, or probably in any Chinese lab.
Oh, I mean, I don't know if I would go that far.
Any lab that's run by the Communist Party of China.
I would say this: don't do experiments with chirality in a non-controlled environment.
Do it on the dark side of the moon.
Maybe do not do experiments with chirality on this planet until we understand more.
That's right. I like that. I like that
So,
point of view.
I mean,
I
can imagine even doing it in the most isolated spot on Earth, like in Antarctica somewhere, and then it's
Right.
still
Well, yeah. We all saw the 1984 version of The Thing, with Kurt Russell, so they were able to isolate that organism there.
So, all right. With all that said, I think we went quite a bit over time because I just wanted to talk about other things.
Yeah, it's your fault.
It's not my fault. I mean, it is what it
No,
is.
I'm just kidding.
I'm not putting a time limit on this, So
I do. I wanted to have it at half an hour, but that's beside.
Just didn't even.
I was targeting 45 minutes.
Okay. I've realized, for our viewers, previously, once upon a time, we could have done an episode in half hour. These days, it's more likely an hour, just because we want to cover something to a great depth.
And it's a lot of fun. So anyway, let's
So,
wrap
with all
it
that
up.
said-
What do you say?
What's up?
Let's wrap it up.
All right, everybody. Thank you for watching the show. This has been episode 223 of SG2. Yes. Is life a cosmic accident? So, if you're also interested in learning about Oumuamua, we also have a past episode on that, which I will drop on the comments later on. With all that said, thank you to Kyle Baker, Sam Welsh, and John Graves for your kindly donations. For anyone interested, you can go to patreon.com/SG2 on space. And of course, like, subscribe, share, comment on this particular channel and this particular video or any other ones in the past. With that, we'll be back next week for another exciting episode talking about something space related. We'll leave it at that.
So anyway, good night, namaste, good afternoon, wherever you are on Earth. We're in the future. 10,000 years in the future.
This universe.
So thanks for checking in. Good night.
Signing out.
Mwah.